Hello, welcome back. So in the previous part, we have calculated reactions of simply supported beam carrying point load and UDL. Now this time we are going to solve this beam. So this beam is carrying uniformly varying load, and we have to find out reaction of this beam. So this beam will offer reaction, like this is the hinge support, so it will offer two reaction, RH and RL, and on this end it will be RR. Okay, so again we have to consider the system is in equilibrium, and now because there is a UVL, now how do we find out this reaction in this case? So generally what we do is we can convert this triangular UDL into a point load. So point load, the magnitude of that point load will be equals to the area of this triangular portion. So this triangle, which is the loading is in the form of triangle. So if we calculate the area of this triangle, so that will be the magnitude of the point load. So now what we are going to do is we will say converting triangular load into point load. So the magnitude of the point load will be, it will be equals to the area of load. So in this case the area is in the form of triangle, so there we will write as half into, now the base of the triangle is 6 meter and the height of the triangle is this one, which is equivalent to 12. So the unit is 12 kilonewton per meter. So we will write here 6 multiplied by 12, so which becomes 36 kilonewton. So now what I can do is I can convert this beam now as the UDL. I have converted this UVL into point load, and where this point load will be located, it will be located at the CG of this triangle, and the CG of this triangle will be something here, which is uh, 2 by 3L from point A and L by 3 from point B. So if I take this value as L, so in that case this will be 2 by 3L and this will be L by 3. Okay, so our load will be acting here, which is 36 kilonewton, and this distance would be L by 3 means 6 by 3, which is 2 meter, and this will be 4 meter. So now it becomes a very simple case. Now in this case, now there is no horizontal load, so obviously RH will be 0. So I'm writing here directly RH will be 0 because there is no horizontal load. So that is why RH will be 0. So now we will use the second equation, which is summation of Fy is equals to 0. So summation of Fy means algebraic sum of all the vertical forces should be 0. So there are three forces actually. One is RL, second is RR in the form of reaction, and the third force is the external load, which we have just converted into a point load. So this time it will be written as RL plus RR equals to 36. So I'm writing this as equation 1. Then we have the third equation, which is summation of M is equals to 0. So this time we will be taking moment as at A. So now we are taking moment at about this point. So the moment of RL will be 0 because we are taking moment at this point, which is point A. So this becomes 36 multiplied by 4 So you can see here about this point, this force will try to rotate like this, which is clockwise. So I'm taking this as clockwise, and moment due to this reaction force, which will be rotating like this about this point, because the direction of this force is upward. So it will be negative. So this becomes RR multiplied by the perpendicular distance is 6 meter. So now RR value will be 24 kilonewton. So now we will put this value in equation 1. So I am just clearing the space. So RL will be equals to 36 minus 24, which becomes 12 kilonewton. So it means this reaction is 12 kilonewton and this reaction is 24, which you can see the maximum intensity is in this region. So maximum reaction offered by this support, which is 24. And you can see in this region, there is less intensity, less load. So that is why the reaction is less. So that is the solution for this problem. Similarly, we can take another example. In this example, there is a overhanging beam, which is overhanging from one end only. So in this case, again, we will be assuming the beam in equilibrium and using the equation of equilibrium. So summation of Fx is equals to 0, which means reaction RH will be 0. Now, where will be the reaction RH? You can see this is the hinge. So this hinge will offer vertical reaction and the horizontal reaction. So this horizontal reaction will be 0 because there is no horizontal load. Then we will be using the second equation, which is algebraic sum of all the vertical forces should be 0. So this is RL and this is RR. So there we will write RL plus RR minus 20 minus 40 equals to 0. So this equation becomes RL plus RR equals to 60, which becomes equation 1. So now we will use the third equation, which is summation of M equals to 0. And this time we will take moment about, we can take moment about any point, but we will be taking moment about any one of the support. So taking moment about B, taking moment about B. So in this case, now we can write the equation, which is 20 into 2.5. So you can see this force will try to rotate about this point like this, which is anti-clockwise. So I'm putting the sign here. Similarly, the reaction RL is about point B. So the moment due to RL will be 0. Then the second force is 40 kilonewton. So you can see this is downward, and about this point, it will be rotating like this, which is positive. So we will take 40 kilonewton multiplied by 3, which is the perpendicular distance between the force 40 and the point B. Then we will take the moment of RR. So you can see the distance between RR and point B is 5 meter, which is the perpendicular distance, and it will be rotating like this, which is anti-clockwise. So I'm writing here RR multiplied by 5. Now we have considered moment of all the forces. No, so now we will equate this with 0. So now after solving this, we get RR value as 24. So we get RR value as 24 kilonewton. Yes. So we get RR value as 24 kilonewton. No, actually, it is 14 kilonewton. So when we solve this equation, we get RR as 14 kilonewton. And then putting this value RR in equation 1, we get the value of RL as 60 minus 14, which is 46 kilonewton. So now you can see RL is 46 kilonewton and RR is 14 kilonewton. So this reaction is less. Why? Because the impact, the reaction is high here. Why? Because there is this force which is completely resisted by this force and some part of this force also. So that is why the reaction at B is higher than the reaction at D. So that is a solution for this. We can calculate this reaction, this beam also. So in this beam, you can see the load is symmetric, which means if we, first we will consider the case of the beam. You can see this is the overhanging beam, and this time overhanging is on both sides. So from this support, it is overhang, and from support B, it is again overhanging. So this beam is carrying a UDL between the support, and on the overhang part, it is carrying UVL. And the intensity of UVL at free end is 0, and at the fixed and at the support, it is 4 kilonewton per meter. Similarly here also 4 kilonewton per meter. So now by looking at this problem, you can see the load is symmetric, which means if we cut this beam half, then we can see that the load intensity or the load is same on the left hand side as well as it is same on the right hand side. So which means the reaction which will be, one second, I will first, this is the hinge support, so it will offer two reaction, which is RL and RH. So RH will be 0 obviously because there is no horizontal load. Similarly, the second reaction will be offered at point B, which is RR. So now I am talking about these reaction. Now, as you can see, the load is symmetric, which means the reaction on the left hand side and reaction on the right hand side will be same. Why? Because the load is same on left hand side and on the right hand side. So therefore we will write here uh, as the load is symmetric, reaction will be same on both support which means load will be distributed equally. Load will be distributed equally on the support. So in this case, now we can write as RL will be equals to RR, and this will be equals to total load divided by 2, which means both reaction will be same. So total load here is load between the support A and B is UDL, which is 4 kilonewton per meter. So the total load because of this will be 4 into the distance. How much distance it is spreading? It is 2 meter. So 4 into 2 plus area of this load. So this will be half into base. Base is 1.5 meter, which is 1.5 meter multiplied by the height, and height is equals to 4 kilonewton per meter. So I'm writing this as here 4, and you can see this triangle is also same. So I will simply multiply by 2 and I will divide this by 2. So this will cross it, and ultimately the total reaction would be 14 by 2, which is 7 kilonewton on each support. So RL will be 7 kilonewton and RR will be 7 kilonewton. So we are able to solve this problem because the load is symmetric, but generally such case uh, rarely found. But if such case occur, then we can simply find out the reaction by simple visualization. So we will continue our discussion. We will solve more problem in the next part. Thank you.